Dear student, today we are going to discuss lecture 21. So in this lecture, we are going to discuss about the deadlock prevention and avoidance, as well as we are going to discuss about the detection recovery from deadlock. So these are the multiple topics, but they are very relevant to one another. So that's why we consider in a single lecture. So in the previous lecture, we have discussed that how deadlock situations is occurs, right? So we discuss about certain points like mutual exclusion, like hold and wait, like non-preemption, and all, right? So basically, if we fulfill all the things, all the parameters that we have discussed, then we say that we are facing the problem of deadlock in operating system. But if one of the pillar we can break, then we can easily say that we can avoid from such kind of things, right? So if we simulate deadlock with table which is standing on its four leg, right? Then if we can also simulate four legs with four conditions which one occurs simultaneously cause the deadlock, right? So like it just like a table, okay, if there is a four legs is over there, and we can say that it can hold each and everything that you put inside or over the table, right? So basically, however, if we break one of the leg of the table, then table will fall definitely, right? So if supposed to be we can break one of the leg, then it can fall definitely. So like that, the same happens with deadlock. If we can able to violate one of the four necessary conditions and don't let them occur together, then we can prevent the deadlock, right? So in this case we say that in this whole scenario, we say that while we are violate one of the conditions, means that four condition, one deadlock is generated when all the four conditions are working same time simultaneously. But if supposed to be we can violate one of them, then we can avoid from such kind of we can prevent from the deadlock situation. So this is the basic agenda of our today's topic. So let us see how we can prevent each of the conditions. Now here we check it out that how we can prevent from such kind of conditions, like we have discussed about the mutual exclusion. We are discuss about the hold and wait, circular wave, and non preemptions, right? So from in the first, mutual exclusion. So mutual section from the resource point of view is fact that the resource can be never be used by more than one process simultaneously, which is fair enough, but that is main reason behind the deadlock, right? So if supposed to be we are going to discuss about the mutual exclusion, that we can say that we cannot share basically shared if supposed to be we have a shared variable, but we are not supposed to be permit that we are at the same time we are only one process can access the shared variable over there. But in case of it's fine that it is execution is good, but at the same time it can create also a deadlock. So if we avoid from such kind of things, then if the resource could have been used for more than one process at a time, then the process would have been never been waiting for any resource. If we can allocate the resources to the process, then no process can wait, right? So it means that the mutual exclusion is not doing over there. So however, if we can be able to violate resources have behaving mutually exclusive manner, then the deadlock can be prevented. So if supposed to be we can provide the resources to each and every process, then it cannot create a mutual exclusion, and then we can say that it can avoid from, or we can prevent from the prevent from a deadlock, right? So like a spooling for a device like printer, spooling can work. There is a memory associated with printer which stores jobs from each of the process into it. Like later printer collects all the jobs and prints each one of them according to first come first served. By using this mechanism, the process doesn't have wait for the printer, and it can continue whatever it is doing later. It collects the output when it is produced. So like we have a multiple jobs, job one, job two, and we can put for the in a spool, and we can access the printer. So although the spooling can be effective approach to violate mutual exclusion, but it suffers from two kinds of problem. This cannot be applied to every resource, right? So we can say that spooling is the best technology, best technique that we can use for mutual exclusion, to avoid from mutual exclusion. That's fine, but there is a certain kind of drawback, or certain kind of problem happen over there. So after some, this cannot be applied to every resource for the same, right? So after some point of time, there may arise a race condition between the process to get space in that spool. There is a certain race condition is occurs over there, certain kind of point of time. Then this is also kind of a problem. So we cannot force a resource to be used by more than one process at a same time, since it will not be fair enough, and some serious problem may arises in the performance. Therefore we cannot violate mutual exclusion for process practically, right? So in this regard, we say that if we can use for the deadlock prevention, and we can use the mutual exclusion. So not always possible to prevent deadlock by the preventing mutual exclusion, making all resource shareable, as certain resources are can't be shared safely, right? So this is the point that we can avoid from such kind of things that is very necessarily which is used. So deadlock prevention can prevent deadlock by eliminating one of the above four conditions, right? So eliminate mutual exclusion, right? So it is not possible to dissatisfy the mutual exclusion, because some resource such as tape drivers and printers are inherently non-shareable, right? So it is not possible, we can say, in the mutual exclusion. Now, second one is the hold and wait. In hold and wait conditions lies when the process hold a resource and waiting for some other resources complete its task. So deadlock occurs because there is can be more than one process which are hold one resource and hold for other in cyclic order, right? So basically, what thing happen if we are going to discuss about the hold and wait. Then hold and wait conditions lies when the process hold a resource, right? Process hold the resource and waiting for some other resource, right? It's supposed to be, we are discussed that in the process P1 required resource R1, but at the same time process P1 also hold R2 and R3 as well, as like so, like that. So deadlock occurs because there can be more than one process which are holding one resource and waiting for other in the cyclic order. However, we have find out some mechanism by which process either does not hold any resource or does not wait. That means the process must be assigned all the necessary resources before the execution start. The process must not be wait for any resource once the execution has been started, right? So it's supposed to be, we can consider or we can provide a such kind of a environment that where the process not hold the resources, not waiting for the resources. So this condition is also applicable in the hold and wait. Hold and wait, hold or wait, negation of hold and wait is either you don't hold or you don't wait, right? Condition is that this can be implemented practically if the process declare all the resource initially. However, this sound very practical, but can't be done in the computer system, right? So because the process can't determine the necessary resource initially, right? So this is the point where we, okay. So this can be implemented practically if we process declare all the resource initially, right? So however, this will sound very practical, but can't done in the computer system because the process can't determine the necessary resource initially, right? So process is a set of instruction which is executed by CPU. Each of the instruction may be demand multiple resource at the multiple time. The need cannot be fixed by the operating system. The problem with the approach is practically not possible. Possibility of getting starved will be increased due to the fact that some problem process may hold the resource for a very long time, right? So this is all about what? This is all about the hold and wait, right? So this is all about the hold and wait. So if we go through resource can get all the required resources before it start execution. Right? So this is avoid deadlock, but will result in the reducing throughput as well as resources are held by the process even when they are not needed. Right? So they could have been used by other process during this time. So second approach is to required approach is request for resources only when it is not holding any other resource. If supposed to be there is a it means that there is a free resources. This may result in the starvation as all required resource might not be available free. Right? So this is all about what? This is all about the deadlock situation in the hold and wait. Okay, so allocate all the resource to the process before they start it can execution. This is where hold and wait condition eliminate, but it will lead to low device utilization. For example, we can say that if a process requires a printer at the later time and we have allocated printer before they start of its execution, printer will remain blocked till it has completed its execution. Right? So this is also one kind of hold and wait. So in the second example, we can say that the process will make new request for resource after releasing the current set of resources. This solution may be lead the starvation as well as. Right? So we have a process P1 holding the R1 as R1 is allocated to P1, but P1 is required R2. P1 is waiting for R2 as well as hold and wait condition is over there. Okay, so this is all about hold and wait condition. Now the third one is the no preemption. No preemption conditions. If deadlock arises due to fact that process can't be stopped, right? Once it start, once it start, we can stop like that. So that condition is also non-preemption. However, if we take resource away from the process which is causing deadlock, when we can prevent deadlock. Now, it's supposed to be if the at the same time it can create a deadlock situation, then we can take a resource and we can away from the same, right? So it also avoid from such kind of prevent from the deadlock situation. So this is not a good approach at all, since if we take a resource away which is being used by the process, then all the work will which it has done till now can be complete inconsistent, right? So it can also a problematic. Consider the printer is being used by another any process. If we take the printer away from that process and assign it to some other process, then all the data will which has been printed can becomes inconsistent, inefficient, effective, and also fact that the process can't start printing again from whether it has left, which cause performance inefficiency, right? So there is a certain point of drawback over there. If we are going to discuss about the circular weight, to avoid circular weight, we can assign a priority number of to each other to the resource. A process can't request for lesser priority for resource. This ensure that not a single process can request a resource which is being utilized by some other process and no cyclic will be performed, right? So like there is a certain approach and is practically is possible or not. So mutual exclusion approach, in the mutual exclusion we can use certain kind of approach like spooling, but is practically if we are implementing, then it is not possible, right? Hold and wait request for all the resource initially. Hold and wait what? So all the requests are we can request for all the resource initially. While we can execute, then we can directly access our request all the resources initially. But if we implement this hold and wait in practically point of view, then it is also not possible to request at the same time, right? So no preemption. Snatch all the resource. So it's supposed to be if we snatching the resource from the process, then we can avoid from such kind of deadlock situation. But if we implement this non-preemption in the practically, then it is also not possible to do the same, right? So circular wait assign priority to each resource and other resources numerically, right? So it is possible in the practically we can use the circular wait as well as, right? So deadlock avoidance. Here we are already discussed the prevention. Now we can how we can avoid such kind of deadlock avoidance over there. So deadlock avoidance is also basically if we are going to discuss about the deadlock avoidance, right? So deadlock avoidance, the request for any resource will be granted if the resulting state of the system could not cause deadlock in the system. The state of system will continuously be checked of safe and unsafe state as well as. In order to avoid deadlock, the process must tell operating system maximum number of resource a process can request to complete its execution as well as. The simplest and most useful approach states that the process should declare a maximum number of resources of each type it may ever need. Deadlock avoidance algorithm examine the resource allocations so that there can be never circular wait conditions, safe and unsafe state, right? So in deadlock avoidance, the request for any resource will be granted first of all, right? And if the resulting state of the system does not cause deadlock in the system, then the state of the system will continuously be checked for safe or unsafe state, right? So such kind of deadlock avoidance, we can also use Banker's algorithm as well as, right? So in the Banker's algorithm is resource allocations and deadlock avoidance algorithm, which test all the requests made by the process for resources. It checks for the safe state if after granting request system remains in the safe state. It allows request, and if there is no safe state, it does not allow the request made by the process. Input to the Banker's algorithm, we discuss about the input of Banker's algorithm. Then maximum need of resources by each process, one of thing. Second thing, currently allocated resource by each process. And third one is the maximum free available resource in the system. The required thing is available. Then we can talk about the avoidance, deadlock avoidance. So as you saw already, most prevention algorithms have poor resource utilization, and hence result in the reduced throughput as well as. Instead, all the things we can try to avoid deadlock by making use prior knowledge about the usage of resource by the process, including resource available, resource allocated, future request, and future release by the resource. If you are aware about it, then we can also use the deadlock avoidance. Most deadlock avoidance algorithm need every process to tell the advanced maximum number of resources to each type of it that may need, right? Based on all the all these information, we decide if the process should wait for resource or not, and to avoid the chance of the circular wait. If system is already in the safe state, we can try to stay away from the unsafe state and avoid deadlock as well as, right? So deadlock can not be avoided in an unsafe state. First thing, a system can be considered to be an unsafe state if it is not in a state of deadlock and can allocate resource up to the maximum available. The safe sequence of process and allocations of the resource ensure the safe state. Deadlock avoidance algorithms tries to not to allocate the resource to process if it will make system in the unsafe state, right? So these are the certain points. In order to avoid deadlock, the process must tell so operating system the maximum number of the resource a process can request complete its execution. Simplest and most useful approach state that process should declare the maximum number of the resource of each type it may ever need, right? So deadlock avoidance algorithm also resource allocation so that there cannot be never circulated wait condition is there. So we can easily define that safe and unsafe state. This resource allocation state of a system can be defined by instance of available and allocated resources and the maximum instance of resources demanded by the process. A state of a system recorded at some random time is shown below. Resource assigned, right? So if there is a process A, B, C, D, and type 1 3012, type 2 0011, 2114, type 4, like that, right? So resource still needed. A needed 1, 1, type 1, 2, there is 1, type 3, there is a 0, type 4, there is a 4, like that, right? So like process still we have needed. So we can say that above the table and vector E and P and A describe the resource allocation state of the system. There are four processes and four types of resources in the system. Table 1 shows the instance of the each resource assigned to each process. But in the table 2 showing the instance of the resources, each process still needs vector E is the representation of total instance of each resource in the system, right? So in the system. So vector P represents the instance of resource that have been assigned to the process. Vector A is represented the number of resources that are not in the use. So a state of system is called safe if the system can allocate all the resource request by all the process without entering into the deadlock, right? So this is the state where we can say safe. If the system cannot fulfill the request of all the process, then state of the system is called unsafe. Very simple point over there. The key of deadlock avoidance avoid approach is when the request is made for the resource, then the request must be only be approved in case of if resulting state is also safe state, right? So here there is a deadlock detection and recovery. If we are going to discuss about the detection, deadlock detection and the recovery, right? So also it is also very important. If deadlock prevention and avoidance are not done properly, then we can say that deadlock may occur, and only things left to do is detect the recovery from the detect or recover from the deadlock. Okay, so if all the resource types has only single instance, then we can use graph called wait for graph, right? Which is a variant of resource allocations graph. Here, so there is a certain kind of vertices represent the process, and the directed edge from P1 to P2 indicates the P1 is waiting for the resource held by P2, like in the case of resource allocations graph, right? A cycle in the right graph is over there, right? So if it means that P1 is allocated to P2, but P2 process P3 and P4 and so on, right? So in this approach, the operating system does not apply any mechanism to avoid or prevent the deadlocks. Therefore, system consider that deadlock will definitely occur, right? So in order to get rid of deadlock, the operating system periodically checks the system for any deadlock. In case if it find any of the deadlock, then operating system will recover the system using some recovery techniques, right? So here there is a surety about it that deadlock can occur, so we can detect that deadlock is occurs over there. But if it is occurs, then we can move for the recovery techniques as well. As the main task of operating system is detecting the deadlock. The operating system can detect the deadlocks with the help of resource allocation graph. Okay, so there is a detection, single instance, multiple instance, detect cycle, safety algorithm. In single instance, in the first point, there is a single instance. Resource type. If cycle is being formed in the system, then there will be definitely be deadlock. On the other hand, in multiple instance resource type graph, detecting a cycle in is not just enough. We have to apply the safety algorithm on the system by converting the resource allocation graph into the allocations matrix as well as, and in request matrix in order to recover the system from deadlock either operating system considered, right? So if we are going to preempt the resource, then we can snatch one of the resource from the owner of the resource process and give it to the other process with the expectation that it will complete the execution and will release this resource sooner. Well, choosing a resource which will snatched is going to be bit difficult, right? So it is very difficult. Rollback to the safe state. If we are going to discuss about the rollback, uh, you know, uh, rollback for the same. So there is a certain points. Resource allocation graph also very important to avoid such kind of things, to avoid from deadlock situation. And we also using the certain metrics as well as. So and the deadlock detection and recovery, uh, you know for the single inheritance, single instance and multiple instance detect cycle and safety algorithm for the resource. If suppose we are discuss about the some certain kind of resources, so preempt the resource, right? So we can say that preempt, first of all, we can snatch one of the resources from the owner of the resources process and give it to the other process with expectation that it will complete execution and will release this resource sooner, while choosing the resource which is being snatched and going to be bit difficult. So this is all about the preempt the resource, first of all. Then rollback. In the rollback to safe state, so system passes through various state to get into the deadlock state, right? So the operating system can roll back the system to previous safe state. For this purpose, operating system needs to implement check pointing at every state, right? So for the moment we can get into the deadlock, we will roll back all the allocations to get into the previous safe state. For the process, if supposed to be, this is all about the resource. For if suppose we are discuss about the process as well as, right? So for the process, we are also saying that to kill a process, first of all, right? So killing a process can solve our problem, but bigger concern is to decide which process to be killed. You know, it's supposed to be for the process, deadlock detection, and it's supposed to be with detection and recovery method. For for the process, we can kill the process if any time quantum. Then killing a process can solve our problem, but bigger concern is that is to decide that which process you want to kill. Generally, operating system kills a process which has done least amount of work until now, right? So it's supposed to be there is a process, there is a required lot of time to be completed. Then if supposed to be you kill, then what thing happened, it can not completed their execution. Kill all the process, this is not suggestible approach, but can be implemented if the problem becomes very serious. Then killing all the process will lead to efficiency in the system, because all the process will execute again from the start, right? So there is a certain it's supposed to be we are discuss about the recovery. Then we can recover with the two certain methods. One is the resources and other one is the process. And in the resources, we can preempt the resource and roll back the resource. And while we are in this regard, we have say about the recovery. Then resource and process is there, two methods. One, if supposed we are discussing about the resource, then we can talk about the preempt and rollback. And the process, we can kill one process and kill all the process, right? So basically, this is all about the things that we have to be covered in the recovery, as well as detection and the recovery in the operating system in the deadlock situations, right? there is a certain MCQs over there. The number of resource request by the process must always less than the total number of the process available in the system, must always be equal to the total number of resources available in the system, must not execute exceed the total number of the resource available in the system, and D must exceed the total number of the resource available in the system. So right answer is the C. So number of resource requests by the process must not exceed the total number of the resource available in the system. That is the right answer. So request and release of the resources are dash. Command line statement interrupts system call special program. So C is the right answer. System calls. Basically, system calls who is the responsible for the request and release of the resources. What is the multi-threaded programming? If supposed to be we are discuss about the multi-threaded program, less prone to the deadlocks, more prone to the deadlocks. Not all prone to the deadlock, and no, none of them mentioned. So B is the right answer. If suppose multiple thread can complete for the shared resources, deadlock arises. In this regard, the B is the right answer. That what is the multi-threaded programming? Basically, more prone to the deadlock, right? So for detection to arise, for deadlock to arise, which of the following condition must hold simultaneously? D is the right answer. That mutual exclusion, no preemption, hold and wait. The all the conditions are fulfilled. Then we can say that it can create a deadlock situation. For mutual exclusion to prevail in the system, at least one resource must be held in non-shareable mode. Process must be uni-process rather than multi-process. There must be at least one resources in the shareable mode and all the mentioned. So A is the right answer. Here, if another process requests that resource, non-shareable resource, the requesting process must be delayed until the resource has been released, right? So A is the right answer. For a hold and wait condition to prevail, for the hold and wait condition to prevail, the process must not be holding a resource, but waiting for one to be freed, then request to be acquired it, right? So in this regard, there is a B is the right answer. For hold and wait condition to prevail, the process must be holding at least one resource and waiting for acquire additional resources that are being held by other process. So B is the right answer. Deadlock prevention is set of method where right answer is A, to ensure that at least one of the necessary condition cannot be hold. Then we can prevent from the deadlock, right? Mutual exclusion like hold and wait, circular wait and all, right? So for non-shareable resource like printer, mutual exclusion, A, printer cannot be simultaneously shared by several processes. For shareable resource, mutual exclusion is required, is not required. So B is the right answer. They do not require mutually exclusive access and hence cannot be involved in the deadlock, right? So ensure that to ensure that a hold and wait conditions never occurs in the system, it must be ensured that D is the right answer. A process, a process may request some resource and they use them before it can request any additional resource. However, it is must release all the resources that is currently allocated. Disadvantage of process being allocated all the resource before beginning its execution. So B is the right answer. Low resource utilization. So this is all about what this is all about the things that we have discussed in in our uh, deadlock prevention and avoidance uh, things, right? So if we are revise our topic with the help of certain few important points in prevention. So we have considered an example of a table, like if supposed to be a table have four legs, and if we are supposed to be go for uh, if we you know you break one of the leg, then what thing happened that the table can fall down, right? So it's like the same situation where we can avoid from such kind of things which is present in the deadlock. It's supposed to be there is a mutual exclusion, hold and wait, no preemption, and circular wait. So these are the four conditions where we say that we can the deadlock can occur. So if supposed to be one of the conditions we can break, then we can avoid from we can prevent from such kind of problem uh, like that. And my detailed description about the mutual exclusion. So you know in the mutual exclusion, we discuss about uh, you know the mutual section from the resource point of view. It is fact that resource can be never be used by more than one process simultaneously, which is fair enough, right? But that is the main reason behind the deadlock. That is the main reason of the deadlock. If the resource could have been used by more than one process at the same time, then process would have been never waiting for any resource. However, if we can be able to violate resources behaving in the mutually exclusive manner, then the deadlock can be prevented. Spooling is a example of mutual exclusion that for the device like a printer, spooling can work. Okay, so there is a memory associated with the printer which stores certain kind of jobs for each of the process into the it. Later, printer collects all the jobs and print each one of them accordingly. Right. So in the first come first serve uh, algorithm, by using this mechanism to process does not have wait for the printer as well as, right. So in this regard, if we are discuss about the spooling, then by using the mechanism the process does not have to wait for the printer, and it can continue whatever it was doing later, right. So if supposed to be there is a multiple job like a job 1, job 2, job 3, job 4, and job 5, right. So it can work on the if supposed to be there is working on the printer and it want to execute, then it can be present in the spooling, right. So although spooling can be an effective approach, right, so it is an effective approach to violate mutual exclusion, but it suffers from two kinds of problem. This cannot be applied to every resource as well as in this regard we have discussed 2 points that we are not able to apply the resource all the resource, and another is that after some point of time there may arise a race condition, right. So it is also a drawback over there. We cannot force a resource to be used by more than one process at the same time, since it will not be fair enough. So some serious problem may arises in the performance. Okay. And then after that we have discussed about the hold and wait. So in the hold and wait conditions lies when the process hold a resource and waiting for the some other resources to complete its task, then deadlock occurs because there can be more than one process which are being holding sorry, holding one resource and waiting for other in the cyclic order, right. However, we have to find out some mechanism by which process either does not hold any resource or does not wait. That means the process must be assigned all the necessary resources before the execution start, right. So in this we have a third point we have discussed about the no preemption. Okay, so in this regard, if we are going to discuss about the no preemption, then deadlock arises due to fact that the process can't be stopped once it starts, right. So however, if we take a resource away from the process which is causing deadlock, we can prevent the deadlock as well as. If supposed to be, we can snitch, right? So this is not a good approach at all, since if we take resource away which is being used by the process, then all the work which is has done till now can become inconsistent, right? So it's supposed to be there is a if suppose we are going to discuss about the printer, right? So like we have a 10 pages, and we can give the command, and after the five printing of 5 pages we can stop the same process, right? So it can it's supposed to be we are going to again we can revise, then it can start from the starting point, right? So that is the thing, that is non-preemption. Consider the printer is being used by the any process. If we take the printer away from the process and assign to some other process, then all the data will which has been printed can become inconsistent and ineffective as well as. So this is the best example of non-preemption. And after that, there is a circular wait. To avoid from circular wait, we can assign the priority numbers to each of the service resource. So a process cannot be request for lesser priority resource. This ensures that not a single process can request the resources which is being utilized by some other process, and no cyclic will be formed. So here there is a condition, there is a mutual exclusion, and there is a certain approach. If we are discuss about the certain kind of point over here, that is the mutual exclusion. So basically, in the mutual exclusion, where the approach is using in the schooling, but if we implement it in the practical, then it is not possible, right? So there is a certain drawback. So that is why there is no possible. So hold and wait. The request for all the resource initially, right? So initially we can request all the resources for each and every process that it may be it required. But if we are implemented in the practically, then it is also certain problems. So it's not possible, to do the practically. No preemption. Snitch all the resource, right? So if it's supposed to be at this continuous form of execution, we can snatch that resource from the process, and we can allocate it to another process. So what thing happened, there is some problem. So we are practically we are not implement it, but in this circular way, assign priority to each resource and order resource numerically. So it is practically it is possible to do the same, right? So deadlock avoidance. So deadlock avoidance, the request for many resource will be granted if the resulting state of the system does not cause the deadlock in the system, right? So in order to avoid deadlock, the process must tell the operating system maximum number of resource and a process can request to complete its execution. Simplest and most useful approach state that the process should declare the maximum number of resource of each type. It may ever need a deadlock avoidance algorithm and all. Safe and unsafe approach. And we have a certain put an example to understand basically what is the thing over here. And after that, we have already discussed the deadlock detection and the recovery. This is very important point where we discuss about the certain deadlock situation. So in this approach, the operating system does not apply any mechanism to avoid or prevent the deadlocks. Therefore, the system consider that deadlock will definitely occur over there. Here, showing that deadlock definitely it can occur. In order to get rid of deadlock, the operating system periodically checks the system for any deadlock. In this, we find any of the deadlock, then operating system will recover the system using some recovery techniques. Like in detection, we have discussed about single instance and multiple instance, and in the single instance, we have discussed about the detect cycle, and the multiple instance, we have discussed about the safety algorithm as well as. And after that, we are discuss certain things about for the resource things. We have preempt the resource and rollback. Preempt and rollback, we have discussed about the resource. And if suppose for the process, we have discussed about the cleaning a process and clean all the process. But there is a certain kind of drawback is over there. And if supposed to be, we are discuss about the basic thing that we are discussing. So today we have just finished about deadlock prevention, avoidance, and detection recovery from deadlock. Thank you very much.